Today our topic is linked list. Before learning this video, please learn previous parts of this video, then this video is more clear for you. So we already learned a linked list is a linear data structure consisting of a group of nodes where each node points to the next node by means of a pointer. Each node is composed of data and a reference to the next node in the sequence. The last node has a reference to null which indicates the end of the linked list. So, there are three different types of linked list. They are singly linked list, circular linked list and doubly linked list. So, there are many operations on singly linked list. What is singly linked list? The first node reference is stored in the external pointer or header and the last node reference is null indicating that the end of the linked list. There are many operations of singly linked list like insertion, that is inserts an elements at any specified position in the linked list, deletion, that deletes an element at specified position in the linked list, searches an element using the given value, or update an element at specified position with the given value. We already learned many operations in our previous video. Today we will learn more operations on singly linked list. Our first function is insert a new node between two particular nodes. Means two consecutive nodes infos are given and you have to insert your newly created node in between those two nodes. So see the discussion first. Insert a new node between two particular nodes. So function name is insert between. Here also we are passing the address of external pointer, that is 600, and x and z are the info of two consecutive nodes. See what is the value of x? It is 33 and z it is 55. So the info of two consecutive nodes are given and I have to insert our newly created node between two consecutive nodes. Say its info is y. Say the value of x is 33, value of y is 44 and value of z is 55. So between two consecutive nodes, I want to insert our newly created node. Okay. So I have to pass the value x, y and z. Now struct node star p star q. P can hold address of any node. Q also can hold address of any node. P equal to star ext means P is the starting address of this linked list, that is starting node address 1000. First, what you have to do? First, we have to create the node. So malloc allocate at the time of run struct node size memory chunk and it returns the initial address of this memory chunk to Q. So what is Q? Q is the starting address of this memory chunk. Okay. And what is Q arrow info? It is Y, that is 44. Now, if the linked list is empty, then P equals to null, that is star ext equals to null. Then it is impossible to insert. So impossible. Otherwise, normal case. So we have to traverse the whole linked list till we get the last node. While P arrow next not equals to null. Is P arrow next is null? No, it is 2000. Is P arrow info is x? Is it 33? It is 11. No, it is wrong. If this condition is false, then the whole condition is false because in between these two conditions there are and when and is there, then if the first condition is false, then the whole condition is false. So what you have to do, see P equals to P arrow next. Come to the else part and P equals to P arrow next. So our new P is this. Again come to this while loop. While P arrow next not equals to null. Is P arrow next is null? No, it is 3000. Is P arrow info is x? No, it is 22 not 33. So first condition false. So the whole condition false. So come to this else part and P equals to P arrow next. So P is this node. Again this while loop. While P arrow next not equals to null. Is P arrow next is null? No, it is 4000. if P arrow info is X, is P arrow info is X, P arrow info is 33. Is it 33? Yes. So this condition is true. Now P arrow next arrow info is Z. Is P arrow next arrow info is Z? P arrow next means 4000. Arrow info means 55. Is it Z? Z is 55. So both conditions are true. When both conditions are true, then we have to insert our newly created node in between these two nodes. So what should be the coding? Q arrow next should be here. You have to give what? Because I want to insert this node here. So Q arrow next should be 4000. From where I can get this 4000? I can get this 4000 after P, means P arrow next is 4000. So Q arrow next should be P arrow next. So see the coding. Q arrow next should be P arrow next. So here Q arrow next, here I have to give 4000, that is P arrow next. Here it is 4000. And P arrow next should be what? P arrow next should be this Q. I repeat, P arrow next should be this Q because I want to insert this node and this node address is Q. So P arrow next should be Q. But see, if I first write P arrow next equals to Q, then I can't get this 4000. So you have to remember this sequence. First you have to write Q arrow next equals to P arrow next, then P arrow next equals to Q. But if you first write P arrow next equals to Q, then you can't get this 4000 because it is erased by the address Q. So first you have to write Q arrow next equals to P arrow next, then P arrow next equals to Q. In this way, you can insert a particular node between those two nodes whose infos are already given. Our next function is delete between two particular nodes. Means two particular nodes infos are given and I have to delete in between those two nodes. So see the discussion first. Delete between two particular nodes means here info of this node is given, say it is 22, it is given, and info of this node is given, say it is 55, it is given. And I want to delete between these two nodes. So these two particular nodes info is given. I have to pass these two nodes info. So one is X, another is Z. So X is 22 and Z is 55. Function name is del between. Here also we are passing the address of external pointer. And the return type is integer because deleted node info part, say it is 33, it should be returned, so it is integer. That's why return type is integer. Now struct node star p star q. P can hold address of any node, q also can hold address of any node. P equal to star ext means p points to the first node of this linked list. If empty linked list, then P equals to null, then we can say that our linked list is empty. It is impossible to delete because no node is there. Otherwise, normal case. Else, while P not equals to null, is P is null? No. You have to traverse the whole linked list. Okay. So, is P is null? No. Is P arrow info is X? Is it 22? No. Then because there is and in between these two conditions, if first one is false, then whole condition is false. No need to check the second one. So what you have to do? P equals to P arrow next. Go to else path, P equals to P arrow next. So the new P is this. Again, while P not equals to null, is P is null? No. Is P arrow info is X? Yes, it is 22. Is P arrow next arrow info is Z? Is P arrow next means what? 3000. Arrow next means what? 4000. Arrow info is what? 55. Is it 55? Yes. Both conditions are true. Then what you have to do? You have to return this 33. Okay. So K equals to P arrow next arrow info. P is 2000. P arrow next arrow info is 33. So K equals to P arrow next arrow info, and I have to return this K. Return K. And Q equals to P arrow next. So this one is Q, free Q. So I have to delete this node, and then P arrow next is should be 4000. From where we can get this 4000? We can get this 4000 by P arrow next arrow next. P arrow next is 4000. So P arrow next is P arrow next. So coding should be P arrow next equals to P arrow next. I repeat, K equals to P arrow next arrow info. So K is P arrow next means here. Arrow info is here. It is K and I have to return K. Q equals to P arrow next. Q is P arrow next and I have to free this location. So free Q. And P arrow next is what? P arrow next is P arrow next, that is 4000. So 4000 should be here. So in this way, you can delete between two particular nodes. Write a C program to implement following operations of linked list. First, insert a new node between two particular nodes. If the infos of those two particular nodes are given and you have to insert your new node between those two particular nodes and delete between two particular nodes. So, see the coding. So, this is our program. This is node structure we already discussed in our previous video. These are required prototypes. End insert function is used for creation of linked list. Display function is used for showing the total linked list, and then insert between function and tail between function we already discussed. So this is our main. So in main I initialize xtptr as null. I declare xtptr in this way: struct node star xtptr means xtptr can hold the address of any node, and I initialize xtptr as null because initially our linked list is empty. Now I write one index. Supply your choice. First one is end insert for creation of linked list. Second one is display for showing the total linked list. Third is insert between, and fourth is delete between. Fifth and sixth are exit and default respectively. Now take the choice. I here use switch case control statement. Case 1 is end insert. First take how many number of nodes user want to insert, then take the info and repeatedly call end insert function for creation of our linked list. And second case is display. Here I call display function by passing the address of xtptr. Case 3 is insert between function. Means I want to insert between two particular nodes. So I take the info of those two nodes, that is NO and NO1. And also I have to take the info of our newly created node. Okay, the node which I want to insert, that node's info, that is Y. And then call insert between function by passing the address of xtptr and those two nodes NO and NO1. In between those two nodes, I want to insert our newly created node, and that node's info is Y. I have to pass three nodes infos. Okay, and then call the function display by passing the address of xtptr for showing after insertion how our linked list looks. Our next function is till between function. So first I write one printf statement, supply the info of two nodes between which you want to delete. Say it is NO and NO1. Then call the function del between by passing the address of xtptr NO and NO1. And this function returns the deleted node info part that is stored in the variable y, and then I print y. Again call display function by passing the address of xtptr for showing the whole linked list after deletion of that particular node. Case 5 is exit, and in another case is the default case. Now this is our display function. We already discussed in our previous video. This is our end insert function. This is already discussed in our previous video, and this is insert between function. This is del between function. I am showing the total program again. Del between function. First C. Node structure and prototype declarations. Then main. This is switch case control statement. This is display function. This is end insert function. This is insert between function. And this is del between function. So pause this video, try to do it by your own. So when I run our program, supply your choice. First I want to create the linked list. So choice number 1, end insert. Number of node you want to insert, say it is 5. So apply the info part of the first node, say it is 11, then 33, then 55, then 77, and then 99. Now I want to see our total linked list. So case number 2, this is our linked list. Now I want to insert between 33 and 55 the node 44. So this is case number 3, insert between. Supply the info part of two nodes which you want to insert. Okay. Supply the info part of two nodes between which you want to insert. Say it is 33 and 55. I want to insert 44. So supply the info of new node you want to insert. It is 44. So see, after insertion, this is our linked list. Between 33 and 55, 44 is there. Okay. Now delete between. In between 44 and 77, I want to delete 55. Okay. So case number 4, supply the info part of two nodes between which you want to delete. Say it is 44 and 77. I want to delete 55. So after deletion, see our linked list 44 and 77. Here 55 is missing. So in this way, you can insert between two particular nodes and you can delete between two particular nodes. Okay. And case 5 is exit. So this is your programming assignment. Write a C program to implement following operations of linked list. Insert a new node between two particular nodes and delete between two particular nodes. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.